Okay, so question 2 on the extra practice problem is this is kind of a classic game theory game for the extended form. It's big monkey, little monkey. So the idea is there's a big monkey and a little monkey, and they like to eat the fruit that's all the way at the top of the tree. Okay, so if big monkey climbs up to the top of the tree and shakes the branch to get the fruit off, big monkey can just get a lot more fruit. Now, the issue is, big monkey has to shake the branch and the fruit falls down to the ground, which means it's not like big monkey can grab all the fruit for himself, right? So if big monkey climbs up and shakes the branch, the fruit falls down. If little monkey's hanging down on the ground, little monkey gets to start eating the fruit before big monkey can climb back down. And same thing, if little monkey climbs up to the top of the tree and shakes the branch, fruit falls down, big monkey gets to eat the fruit before little monkey can come down and start eating the fruit. Now the big difference here is that big monkey is big and he can shake the branch and get a lot of fruit, whereas the little monkey, if he climbs up to the top of the tree, then when he shakes the branch, not as much fruit falls down, right? And so that's kind of the outcome of the game. All right, so each monkey has the option to either wait and see if the other person is going to climb the tree and shake the branch, or just climb the tree and shake the branch, right? And so big monkey has two options. He can either wait or climb and shake the branch. And then little monkey, depending on what big monkey does, can also do the same thing. Can either wait or climb. So the idea is big monkey can climb and little monkey can wait and be like, ha, I'm going to get some fruit and I don't have to do anything, right? Or big monkey could wait and make little monkey climb, and then big monkey gets fruit, but he doesn't get as much, right? Or they could both wait, right? It's like a staring competition, and they're both waiting to see who's going to break and go up the tree, and maybe neither of them do, right? Or they could both climb together, shake the fruit, and then they're, of course, going to get jointly probably a little bit more. So that's the idea here. Okay, so the extensive form of the game is here. So let's go through and do parts A, B, and C. And remember, with these types of games, the easiest way to work through it is to just list out all the different possibilities or combinations, right? And in these games, where they're sequential games, where each player goes in turn, you can oftentimes have multiple Nash equilibria, and some of them maybe just don't make the most sense, and so we've got to figure out which one's the most likely one. And that's where the idea of subgame perfect Nash equilibrium comes into play. So let's start off with part A, where we just find all the different possible Nash equilibrium in the game. All right, so the easiest way to do it is just to list all the possibilities. So we've got big monkey here. I'm going to just abbreviate it with big M. And then we've got little m, little monkey. So big monkey can either wait or climb. We're going to do W for wait, okay? And little monkey, remember, we're analyzing the game before it's played. So little monkey's got to figure out what he's going to do in the scenario where big monkey waits, and little monkey's got to figure out what he does in the scenario when big monkey climbs, right? So again, there's two possible scenarios here. So little monkey can either wait and wait, so that is wait at the top game and wait at the bottom game. So the first one here, this is for the top one, and then the second one here, this is what he's going to do on the bottom one, right? That's the idea. So he can wait or he can wait and climb, C for climb, or he can climb and wait down below, or he can just climb whether he's at the top or the bottom, depending on which part of this tree, okay? All right. That means, and actually maybe I'll stick with red. Down here, big monkey, if he climbs, little monkey again still has the same options. Wait and wait, don't climb, basically. Wait and climb down below, climb above and wait down below, or climb whether you're in the top little game tree or the bottom little game tree. All right, so now let's go through here and figure out which ones are potential Nash equilibria, or the better way to think about it is, let's cross off the ones that are not Nash equilibria. All right. So here we go. Let's switch to blue. Okay, let's look at the first one here. Okay, let's take a look at this one. That is, big monkey is going to wait, and little monkey is going to wait. It's like a standoff, and neither one is going to flinch. Okay, so if it's wait and wait and wait, that basically means we're currently at this point here. Okay, and let's see if each player in turn would want to deviate. Well, let's ask little monkey first. Given that we're here, would little monkey want to just go ahead and climb? And if so, they move from getting 0 to 1. Yeah, they would. So we can cross this off. That is not a Nash equilibrium. Okay? All right? So let's get rid of that. Let's get rid of that. Okay. Let's go to the next one. In this case, big monkey waits. Little monkey waits up here and then climbs down below on the second game tree. Well, we already know little monkey is not going to wait up here. We already know little monkey will always want to climb up here, so we can cross this one off too. Okay? All right. So let's move on to the third one. Big monkey waits, and little monkey climbs up above, but then waits down here. So we're currently here. Okay? And we know, okay, little monkey would not want to switch. Little monkey up here would not want to switch his choice from C to W. He wouldn't want to do that because he'd go from making 1 to 0. Okay? So now let's take a look at big monkey. Well, currently little monkey is playing climb up here and wait down here. So this is the other potential option here. Okay? All right. So would big monkey want to switch to climb and earn 4, or does big monkey want to stay right where he is earning 9? The answer is yes, he would want to stay right where he is. So therefore this is the first Nash equilibrium. Wait, and then little monkey climbs and waits down below. Okay. All right, so let's go to the next one. Next one. Big monkey waits, and little monkey climbs regardless. That is, little monkey climbs at the top part, at the bottom part. So that means we're here again. Big monkey waits, and little monkey's going to climb. Okay. So again, we know little monkey would not want to switch from 1 to 0. So we're okay on that. Okay. So far, so good. Whoa, that was not what I meant to do. Now, let's look at big monkey. So currently, a little monkey is going to climb regardless, right? So big monkey is now looking at either staying where they are, right here at 9-1, or if big monkey switches to climb, stop it, then he would move from 9 down to 5. Remember, big monkey is player 1, and his outcome is the first one listed. Well, big monkey's not going to want to move. So this also is a Nash equilibrium. So now we've got 2. So far we've got W, CW, and W, CC. All right, so now let's move down below. And let's erase this. Okay. So let's do, okay, big monkey's going to climb, and little monkey's going to wait. So climb and wait down below. That means we're here. Okay? Okay, well, let's ask little monkey. Little monkey, do you want to wait, which is what you're doing, or do you want to switch to climb and earn 3? Well, no. Little monkey is happy waiting down below. So far, this could potentially be a Nash equilibrium. Now, what about big monkey? Given that little monkey is going to wait, does big monkey want to potentially switch and go up here? Well, the answer is no, right? Because if little monkey is playing wait, right? This is the one we're looking at here. Wait regardless. That big monkey's 2 options are either staying here and earning 4, or moving up here, given that little monkey is going to play wait up here and earning 0. Well, big monkey doesn't want to switch, so here we go. That also is a Nash equilibrium. So now we're up to 3. All right. Now, the other ones down here we can rule out pretty quickly. We know down below that little monkey always prefers wait. So if little monkey's always down here, they're always going to prefer 4 to 3. Okay? So that means they're never going to climb if they're down in this tree. Okay? So that means we can rule out that one, and we can rule out that one. All right, so the last one we want to analyze is this one here. That is, big monkey climbs, and little monkey climbs up here at the top tree, but waits on the bottom tree. That means we're here again, okay? So we know little monkey is happy here waiting down in this game, because if they switch to climb, then they go from 4 to 3, and they don't want that, okay? All right. What about big monkey? Well, if little monkey is going to climb up here and wait down below, then this is the other potential scenario here, 9 and 1. So now let's ask big monkey. Does big monkey want to switch from climb to wait? If so, they would move from earning 4 up to 9. Yeah, you're darn right they would want to switch, because they can make themselves better off. So that can't be a Nash equilibrium. So there we go. We basically have 3 Nash equilibria. So we've done part A. Find the Nash equilibria of this game. Part A, the 3 Nash equilibria are big monkey waits up above, big monkey waits, and then little monkey climbs up above and waits down below. Whoops. Let's undo that. That's a really weird looking W. The other one is big monkey waits and little monkey climbs, whether they're in the top tree or the bottom. Sorry. Top bracket or the bottom bracket. It's unfortunate it's also about a tree. The third Nash equilibrium is big monkey climbs and a little monkey waits. Okay. So which one of these is the subgame perfect one? So for part B, which one is subgame perfect? Well, subgame perfect means the one that results in the outcome of the game in each of the subgames, right? So we know little monkey up here is always going to climb, okay? And down here is always going to wait, okay? So any of these that has climb down below, i.e. this one, right? That's not subgame perfect, SPNE. Right? Because little monkey is never going to climb down below and earn 3. That doesn't make any sense, okay? And let's see. Any of these outcomes that has waiting up here, little monkey is never going to wait up here, because little monkey would get 0. Little monkey is always going to climb if they're up here. So this one, where little monkey waits regardless, is also not SPNE. So that means this one, which makes the most sense, that is, big monkey realizes that little monkey is going to climb regardless. And so big monkey chooses to wait, little monkey climbs, big monkey then collects a whole bunch of the fruit. Right. And this is going to be our SPN.